Alrighty, this is section 6.4 again, and we're still looking at logistic regression, but now we're gonna look at our transformation. Okay, so under the best of circumstances, we'll keep going with the score and the probability. So you'd have some score, and here you would have P for a probability of success. And again, this could be 1, this might be 0.1 and 1.5 and 0.2 and so forth, and maybe up to 4, and you get 0.95 or something like that. And you would have a bunch of data like this. And then what you'll want to do actually is work with, instead of P, you're going to want to calculate the natural logarithm of P over 1 minus P. So, this first one would be the natural log of 0.1 over 1 minus 0.1. And you would evaluate whatever that is. Again, a spreadsheet will do this just fine. We'll look at that in another video. Natural log of 0.2 over 1 minus 0.2. And, do that all the way down. And now you would want to look at those data and those data. And I kind of did that using our sigmoidal curve here, just in Desmos. So, our original sigmoidal curve was this P of X, and I'm going to turn that off for a minute. And so you may have these data that look like this, and so I gave a plot of those, and again, well, if I turn that back on, you can see they really are following that particular sigmoidal curve very well. And I would have reason to believe they should, because there are these probabilities of success and so forth. But the problem is, that sigmoid is not a straight line. And so if instead, though, I do that natural logarithm of the probability of success over the probability of failure, I get these blue dots here. We can maybe make those show up a little better. There we go. We get these blue dots, and those are much more in a straight line, and I can again show that straight line there. And so, that's the idea, is we simply are going to transform our y values, so to speak, our probabilities, and do them using that natural log of the y value over 1 minus the y value. Okay. Now, going back to this, though, I say in the best circumstances, you get this kind of thing. Actually, what tends to happen instead is, as we started out, you've got a score, and then you have just a success or failure, right? So success, failure. And so you might have a 1, a 1.5, a 2.1, and so forth. And that success failure might be a failure at a 0, might be a 0, might be a 1, and then a 0, and then a 1, and those kinds of things. Well, the problem is, if I go to take the logarithm of 0 over 1 minus 0, that's the natural logarithm of 0, which is undefined. So that doesn't work so well. And similarly, if it were 1, I would have a natural log of 1 over 1 minus 1, which is natural log of 1 over 0, oh, that's undefined as well. And so if your data are these zeros and ones, you have a problem in doing it with this particular transformation. Now, the more sophisticated softwares and so forth, they'll handle the zeros and ones just fine, and you won't ever know the difference. But for us, well, you know, we are going to just use our regression template to do this. So we have to get our data transformed first. But what are we going to do? Well, actually, a good heuristic. Now, a heuristic is an algorithm that gets you close to the best answer, or the right answer, so to speak. Okay, so there are lots, in math, there are a lot of heuristic algorithms because we maybe can't solve something exactly, and so we go to these heuristics. Well, a good heuristic here is to kind of do two transformations. So you got your score, 1, 1.5, 1.7, 2.1, and so forth. And your original success or failure, and 0, 0, 1, 0, and so forth. Well, now, instead of 0 and 1, use something like 0.1. 0.1. So this is our first transform. And 0.99, 0.1, and so forth, all the way down. And then you use that data to do your second transform of the natural log of 0.1 over 1 minus 0.1. And you can use 0.1, you could use 0.01, so right, I could just change that to that, and that'd be a 9 and a 0.01. And what this does is it gets us much, much closer to the real data of zeros and ones, but these are defined. And so that is the transformation process we're going to use. We're going to then fit that data, and as you know, we're going to get coefficients. And so, what we'll end up with is something like the natural log of our success failure, or our probability. So I'm just going to call it a P, a probability over 1 minus the probability is equal to some bx plus a, where a is our intercept. So we'll have that. That's what will come out of the regression. And then we can solve for P in this equation. We can do some algebra, and this is in your textbook. It just gives the, well, let me go ahead and, we don't have to repeat this over and over, but I suppose to see it once is not a bad idea. I'll exponentiate both sides, so P over 1 minus P is e to the b x plus a. Multiply both sides by 1 minus P, and I get P is equal to 1 minus P times e to the bx plus a. distribute that through. So I have P equals e to the bx plus a minus p e to the bx plus a. Now let's move the terms with p over to the left-hand side. So I got p plus pe to the bx plus a equals e to the bx plus a. Factor out the p and divide, and I get p equals e to the bx plus a over 1 plus e to the bx plus a. And so we can just, we can go from here where we know we've got bx plus a all the way down to here. Now, if it's multiple regression, then we just end up with our natural log of p over 1 minus p is equal to b1x1 plus b2x2 plus, all the way to some bn xn and plus a. And then p would equal e to the b1x1 plus b2x2, all the way out here to plus a over 1 plus e to the bx1 plus bx2 and so forth plus a. Okay, so that's what, we will use our multiple regression capability to do that. We can do it just like in module 6, where we're trying to find our best choices of the B's here. And we might have interaction terms, and that's fine. If I tossed in here b1 2 x1 times x2 for an interaction term, that's fine. It doesn't care. b1 x1 x2, kind of messy there, but we can have our interaction terms and so forth, and get rid of things as we look at our adjusted R squared. We'll look at our adjusted R squared for this, and then once we've decided on that model, then we can transform back to this. And there we go. That's the transformation process. And so we'll do some video where I use a spreadsheet and actually make these transitions happen.